All right, today we're going to be doing 6.4. This will be the last and final new lesson that we will have before midterms. And today's lesson is about the percent of increase and decrease. There is a formula you're going to want to have memorized. The actual test over chapter 6 will not be until January, but on that test you are going to need to know all of these formulas. So if you would, please pull out your red pen and go ahead and write this formula down. In order to find the percent of change, you have to take the amount of increase or decrease and divide it by the original amount. So if I were to abbreviate that, I would say P equals AOC over the original. Does anyone have a guess of what AOC might mean? Hayden, that is correct. AOC means the amount of change. How much did it change? How much did it increase or decrease? And then we're going to divide that by the original amount. All right, the instructions for number 1 say to find the percent of change as an increase or a decrease, and then round to the nearest tenth. So we've got something that's 10 inches and it grows to be 25 inches. What could we have that grows like that? A pet dog. Okay, so maybe when he got, I don't know if there's any dog, I guess there could be a dog that's 10 inches long, okay? So maybe when it was a puppy, it was 10 inches long, and it grew to be 25 inches long, all right? So the first thing we're going to start with is our original formula. So let's write this down. AOC, the amount of change, over the original amount. So in order to find the amount of change, you're going to take the biggest amount and subtract the smallest amount. So what was the longest that this dog got to? 25 inches. And then I'm going to subtract how much it started at. How long was it when it was born? 10. Over, it says the original amount. What was the original length of that dog? Right there, it tells us. 10 inches. He was 10 inches when he came out. Okay? Let's do the numerator first. What's 25 minus 10? 15. We're going to divide that by 10. Now, class, can 15 tenths be reduced at all? Yeah, what number goes into a 15 that also goes into a 10? A 5. Divide by 5 on top and on bottom, and what do you get? 3 over 2. All right, let's just figure out what that would be as a decimal. How do I figure out what 3 over 2 would be as a decimal? You're going to divide 3 divided by 2. Guys, what is 3 divided by 2? 1.5. Now, the instructions have asked me to find the percent. Do we know how to turn a decimal into a percent? How do I do that? Move it to the right 2 times. 1, 2. What do I put in that little egg carton? A 0. So what is the answer? 150%. Now, if the dog started off as 10 inches and it grew to be 25 inches, did it increase or decrease in length? It increased. It got longer. So this is a 150% increase. Let's do another example. There were 65 people, and then there were only 57 people. So let's imagine maybe 65 people went to a party, and then at the end of the night, only 57 of them were still there. Find the percent of change as an increase or a decrease and round it to the nearest tenth. Those are our instructions. So let's first start off once again with our formula. What's the formula I'm going to use, class? AOC divided by AOC over the original. Remember, AOC is the amount of change. Ava, how do I find the amount of change? Very good. We start with how many people there were, the bigger amount, 65, and subtract the smaller amount. Trenton, originally, how many people were at this party? 65. Isaac, what's 65 minus 57? All right, we've got 8 over 65. How do I get that to turn into a decimal? Divide. Angeline, what do you get when you divide? All right, wow, this is a big number. 0.12307. I kind of ran out of room, so I'm going to stop it right there. What one of those numbers can I get rid of? The 0 that's there at the beginning, we don't actually need that one, okay? Now, we know that we have to turn this into a percent. What do I do with my decimal point? Move it to the right 2 spots. Okay, which now would leave me at like a 12.3076, keeps going, okay? It asks us up here in the instructions to round it to the nearest, what? 10th. Which number is in the 10th place? Guys, it's the number right after the decimal point. The 3. The 3 asks his neighbor right there next to him, hey, are you 5 or bigger? What's that 0 say? No. So should my 12.3 stay the same or should it get bigger? It stays the same, 12.3%. Now let's think. We've got to say whether it's an increase or a decrease. If there were 65 people and at the end there were only 57, did the number increase or decrease? It decreased. It got smaller, okay? Maybe some people were tired and they left the party early or they had to go somewhere else, all right? So there was a decrease in the number of people. So let's look at the next one. Let's imagine that there was a giraffe, okay? The giraffe was born at 8 feet and it grew to 24 feet. I want to know how much it changed. What was the percent of change over the first year of its life? Okay, let's start with our formula. What's the new formula we've been using? Very good. The amount of change over the original amount. I want you guys to try to do this on your own and see what you come up with. All right, as I walked around, I saw quite a few people who were very close to the answer, a couple people who got it. So let's see where you fall in that line, okay? How do I find the amount of change if the giraffe started off as 8 feet and it grew as tall as its mother, 24 feet? How do I find that amount of change?
24 minus 8.
Very good. 24 minus 8. You always take the bigger number and subtract the smallest number. Because you don't want to do 8 minus 24. You would get a negative number, okay? Originally. A lot of people mess this part up. How tall was the giraffe originally?
8 feet.
8 feet. Okay, what's 24 minus 8?
16.
16. What's 16 divided by 8?
2.
2. I want you to think about, let's imagine that I tell you, hey guys, I found $2 on the ground. $2 means the same thing as $2, right? So where is the decimal on this 2 for the amount of change? It is behind the 2. A lot of people messed up and didn't put it behind the 2. Now, to change this to a percent, what do I do with my decimal?
Carry it to the right twice.
1, 2. A lot of people only moved it one time. Now remember, think about the egg carton, right? What do I put into that egg carton? 0. So I need to put 2 zeros. Now, what percentage would that be? 200%. Did this cute little giraffe grow bigger or grow smaller? So is that an increase or a decrease? That would be an increase. Raise your hand if you got that correct. Only a couple of people. When you're trying to figure out increase or decrease, look to see what it says it was to start with. It was 8 feet and it went to 24 feet. So that has to be an increase. If it were the opposite, it was 24 feet and now it's 8 feet, that would be a decrease. Okay, for problem number 2, it says the table shows the number of hours you spent online last weekend. What is the percent of change in your time spent online from Saturday to Sunday? Now here's what's interesting. How many of you would say you definitely spend more hours online than just 2 or 4.5? How many of you have ever had that thing on your phone that shows up and it says your average screen time was either higher or lower than it was last week? How many of you have ever been mortified at how much time it says you spend on your phone per day? You think, man, I was only on that thing for half an hour and it says my average is like 4.5 hours a day, and then you wonder. So be careful. Try not to spend too much time online. But let's go back to the problem, okay? We're going to start with our original formula. Einar, what's the original formula we've been using today? Very good. We're going to take the amount of change and divide it by the original amount. Huang, how do I find the amount of change? Okay, take the biggest number, 4.5, and subtract it by the smallest. Hayden, what was the original amount of hours spent online? 2, very good. Okay, Saturday was 2 hours. Okay, so our amount of change is 4.5 minus 2, 2.5. divided by the original amount, 2. Guys, what's 2.5 divided by 2? What is it? 1.25. Now, do I want it as a decimal or do I want it as a percent? We do want it to be a percent, so we're going to take that and move it 2 places to the right. And what do you get? 125%. Now, did it increase or decrease? It did increase. You only spent 2 hours on Saturday, but you upped it to 4.5 on Sunday, giving you a 125% increase. Question number 3 is given us a bar graph, and it shows a softball player's home run totals. What was the percent of change from 2016 to 2017? Round to the nearest whole percent. Now, if I'm looking at this graph right here, what year does it give us the first amount of data? 2014, okay? Then it gives us 2015, 2016, and 2017. What 2 years does it tell us we will be comparing? Okay, the final 2. So really, it kind of puts this there to distract you. We don't need 2014 or 2015. So we're just going to focus on the bottom, 2016 and 2017. Let's start with our formula. Just the boys, what is the formula we've been using today? Very good. We're going to take the amount of change over the original. Always start by writing that formula for me, please. Brayden, how do I find the amount of change from the year 2016 to 2017? Very good. We take our bigger number 28 and subtract it by the smaller number 20. Noah, what was the original amount in 2016? Very good. They made 28 home runs. Angeline, what should I write next? Very good. 8 over 28. And Talila, what would that be as a decimal? .28571. I'm going to stop right there because I kind of ran out of room. Okay, very good. Let's move that decimal 2 places to the right because that's how we can change it to a percent. If I drop that down, I'm at like a 28.571, and it keeps going. Now, up back here in the instruction, it says round to the nearest whole percent. What's the whole number there? 28. Everybody underline that 28. Okay, so the 28 asks his neighbor right there, are you 5 or bigger? What's the 5 say? Yes, so does the 28 stay the same or get bigger? So what would it be? 29%. And did it increase or decrease? Look right here, guys. In 2016, they got 28 home runs. In 2017, they got 20. It was 28 and it went down to 20. So was that an increase or a decrease? That is a decrease. Okay, so does it seem like this softball player is getting better or worse? Unfortunately, she might have already hit her prime. All right, there is one last and final new formula that I'm going to give to you today, and it's the percent error formula. This is the percent that an estimated amount differs from the actual amount. And if I were to write it as the formula, the percent of error is the amount of error over the actual amount. All right, take your pencil, go ahead and draw a little cloud around it so that that formula sticks out for you. All right, you fill bags with about 16 ounces of homemade dog treats. Where do you think you could go and buy dog treats at? PetSmart would have some, okay? Walmart. Lots of different stores are going to sell dog treats, okay? These ones are being made at home. Here's the deal. They are going to be sold. The acceptable percent of error when filling a bag is 5%. Listen, they know they're not always going to be perfect, but they really want it to be close to what amount? 16 ounces, okay? We need to figure out whether or not the bag is acceptable. In order to do this, we're going to use this new formula that I just taught to you, the amount of error over the actual amount. So let's look at this as our first example. The first example is you fill up this bag and you put 15 ounces into it. What was the amount that we actually wanted to have in the bag? We wanted 16 ounces. So in order to find how much error or how off you were, you're going to take the biggest number and subtract the smallest number. And divide it by the actual amount that was supposed to be in the bag. How much was supposed to be in the bag? It was supposed to be 16 ounces. What do I have next?
1 over 16.
1 over 16. Guys, what would that be as a decimal? Not 16%. 0.0625. Turn that into a percent, and what do you get? 6.25%. Would this be acceptable? No. Why is this not acceptable? This is what it says. The acceptable percent error when filling a bag is 5%. What percent did we get? 6.25%. That is above 5%, which means that is not acceptable. Okay, so if you were working for someone, they might fire you because you are not counting those dog treats the way that you're supposed to be. So that would be not acceptable. But it seems as though your employer is trying to be kind to you and give you a second chance. So you tried for a second time. And this time, how much was in bag B? 16.5 ounces. First off, how much was your error? You take your bigger number and subtract the amount it was supposed to be, right? And that will give you your amount of error over the actual amount. How much was the bag supposed to be? 16. Guys, what's 16 and a half minus 16? Not 5. 0.5. And what is 0.5 divided by 16? 0.03125. Now turn that into a percentage, and what do you get? 3.125%. What do you think now? The question is, tell whether or not the bag is acceptable. Would that be acceptable? Okay, Gavin, why is it acceptable? It is under 5% error. You only made a 3.125% error. So they would say, yes, that is acceptable because your error was not too great. Since they gave you a second chance, they are going to allow you to continue working at that store. All right, so tonight's homework is going to be doing your midterm review sheet, problems number 1 through 20. You may not use a late pass on it. You may not use a homework pass on it. You must actually do it, and this is worth 10% of your midterm grade, okay? This does not need to go on to big ideas, but please make sure that you have done problems number 1 through 20.